everyone. My name is Devis Tuia. I work for EPFL, and here I lead the lab of environmental computational science and Earth observation. And today I want to bring you to the journey to Africa, basically. And I want to show you our developments that we did in the last 5-6 years about empowering rangers of national parks for making digital animal conservation. So it's going to be a lot of deep learning, but it's going to be mostly working with technology to protect nature, and in particular, this very nice animals that you see in the image just here in the first slide. So if you're not convinced that this problem is relevant, because it's very different from the problems that we have seen so far, well, in an optic of nature conservation, it is actually very, very important to think about the loss of biodiversity. And many animal species are now threatened. And as you can see here in the slides, for example, that in South Africa only, the rate of poaching has been increasing massively. And even if there is a decrease because action are becoming effective, the many species, white rhinos, for example, are on the brink of extinction. So that's something that requires our attention, at least from the scientific community, and also, you know, for the future of the planet. So basically, this story started in 2014 when we entered in contact with natural reserves here in Namibia, at the brinks of the Kalahari Desert. And the reserve is called Kusikos. It's a beautiful place, and basically we got in contact with the managing team, and they wanted to see if it was possible to accelerate the censuses they have to do every now and then to know how many animals they have around, if they have enough to eat, and to see if poachers are around and are killing their animals. So, you know, we thought, okay, no problem. We know about drones, we know about machine learning, so we come with our drone in a suitcase, and it's going to be very easy. We just take a bunch of images, and that's it. And of course, we were very, very pretentious back in the days, but we still managed to put together a team on a project we called Southmap, and it's a project that is still very active. And basically, the thing we had in mind was to have here the Kusikos Reserve, to take a consumer camera, something very cheap, and that we can put on a drone that is not too expensive. So, you know, if it crashes, it's not too bad because it's not a $100,000 worth camera, and basically take a bunch of images and end up with a deep learning algorithm like the one that Ravid presented before, that will basically bounding box animals all over the place. And if we have all these detections, then it's very easy to count. And we can say to the rangers, okay, you have X animals in this region, in the morning they go there, in the afternoon they go there, and so on and so forth. So as I told you, we were very pretentious. So we took the images, and the images look like that. So this is usually the time where I play the game with the audience, but I have very limited time. So I'll skip the game, but I invite you to look into this image and to focus on finding the animals. And I mean, I'm pretty sure everybody can very simply see these animals in the middle. I mean, I chose my image very well. So the animals are there in the middle. And if you are now playing, and I hope you see the image at sufficient resolution, well, maybe you have started to see some more. Like here on the left side, there are 3 animals. I'm not sure if you've seen them. If you found those 3, you've done a terrific job, but actually there are many, many more. And so this shows you how this problem is inherently difficult. It's not just any off-the-shelf deep learning YOLO algorithm will detect your animals in the wild. You need to work a little bit, to make your model work a little bit harder to find them. Also because not only the animals are difficult, but the background is all the time changing. So sometimes you have very reddish background, sometimes it's gray, sometimes it's underwater, and basically your deep learning algorithm needs to be robust to all these different environmental conditions. So basically we were humbled a little bit by that, by the, of course, failure of first tests, and then we decided to do things well. So we started by the principle that unlike buildings, animals is not something for which you find a lot of ground truth around. So the first thing that we needed was to obtain a lot of ground truth that will be of good quality and in a time that would be interesting for a ranger. And basically what we did is that we teamed up with iRevolution and AIDR, so AI for digital response. And we basically developed an app for tablets and smartphones where the crowd, volunteers, geo enthusiasts like you, were basically looking into images and clicking when they were finding images. And with such an application, we had 26,000 images with roughly 1,000 animals. And in 2 days, every image was seen by 5 people at least. And with that, we were able to have this ground truth we were longing for in order to train deep learning models. Okay, so it looks a little bit like that. So you see here in the image on the left, you have all these red lines, and these are like annotations of single volunteers. And when we had more than 3 at the same place, we were considering that that was an animal. And with this, we finally had the ground truth to train a model that, given an image, like this beautiful image of the pelican on the left, will tell you, okay, there is an animal here. So as you can see, we don't bounding box the animal because for the census, this is not necessary, but we do simply detection. So we basically downscale the image resolution to a lower resolution grid, and it becomes a grid classification detection where we want the model to tell us to give a high score here because it is the center of the animal. So of course, it's a deep learning model. This is a seminar about deep learning, and my colleagues before has explained very well how deep learning is, so I won't come back to that. Just to give you the parallel, here on the left you have our image from the drone, and on the right, this is the result that we want to get at. In the middle, it's some kind of ResNet type of architecture that we train in a very problem-specific way in order to be able to detect the animals. You have all the details on this paper here at the bottom. You can just look on archive, and I just don't have time to go into the details, but I want to show you a couple of results, which is probably more interesting now than talking about the architecture. So basically, looking at a very independent test set on this same natural reserve, we were able to decrease the number of false positive of state-of-the-art models from 20,000 to 800 when we were detecting roughly 90% of the animals. So, I mean, that's a massive decrease of false positives, which also means that a ranger that needs to check the detection of your models only needs to check 900 points and not 20,000. So that basically not only accelerates the census because you don't have to fly an helicopter and look for the animals, but you do it with the drone footage. And on top, also the verification is very quick. So we keep working on that, of course. And since 2018, so in 2 years, we basically pushed up the curve from the red one we've seen here before up to this orange one. So basically, 80–90% accuracy for an 80–90% detection rate. So it's pretty neat. We're very happy. And of course, we could have stopped here and say, okay, problem solved. We flew a drone. We have something that works routinely. But we thought that rangers had also other needs. They're not just looking for accuracy. I saw before in the poll that people are mostly interested by models' accuracy, but sometimes, there are other things that run into play. For example, it was very unlikely to be able to repeat the crowdsourcing study. Rangers don't want the images to go out in public because they don't want poachers to see where the animals are in the first place. I mean, if you're a poacher and you know that every second day there is a full coverage of the reserve with animal locations, I mean, you will be a volunteer as well. So we wanted something that didn't require drawing bounding boxes because that's very time consuming for the rangers. So then we started to evolve the model into something that will require less annotation load. So for example, in this study that was published at CVPR workshops, we looked if it was possible only by having a look at the image and saying, there are animals or there are not animals, so not even touching the image, just giving image level labels, if it was possible to localize. And you see here, for example, we have this image here where a deep learning model trained only with annotation of people saying there is something or there is nothing, the model was constrained to be able to even localize the animals. Of course, it makes mistakes. Here there is a mistake. I don't know if you see my mouse, but this is a type of localization that you can obtain for free. And if you provide 1 or 2 annotated images, so we're talking at the same level that Frank was talking about the Pictera type of supervision, so just 1 image, we can then make detections that are much, much sharper and match the result of fully supervised model. So you see here in violet a model that is completely supervised, like with the whole training set labeled, and in red, it's the model trained with 3 images labeled, and the rest just a yes or no type of supervision. So this really accelerates a lot the type of results you can get and the time you require to get there. But again, we decided that this was not enough, because so far we were always just concerned by getting some data, mapping a result. But actually, we can work together with people, so with rangers, with volunteers, that can actually validate or invalidate the model prediction. So imagine you're a ranger and you see the detections, and you tell me, oh, this one is a tree, this is not an animal. This one is a dead tree, it's not an animal. Or another ranger will tell me, oh, look at these 3 animals, you have missed them. And then you can provide this annotation, the model can train specifically on those and improve and become more accurate. This way of thinking is called active learning, and we basically developed a solution for rangers and ecologists that integrates this principle. So what do ecologists need? They basically have a ton of data and they want them to be processed, and they don't have the time to do it. Very often they do not have machine learning expertise, and not everybody can hire a data scientist. So, you sit on data and you don't know what to do. Rangers, they want to go out very often with their drones, and they don't want every time to do crowdsourcing because they're a bit nervous about poachers, and also because they simply don't want their images to be out there. So for all that, for all these people, we developed, together with Microsoft AI for Earth and my former university, Wageningen, a platform called AID. And in AID, basically, we integrate this principle. It's a platform where people that can be ecologists, rangers, nature lovers, data scientists, you can upload your data. They can be about wildlife, they can be about whatever you want, actually. And in AID, you basically have a bunch of deep learning models already there built for you. The model with the pre-trained model will basically take your data, make prediction, and come back to you for verification. And every time you verify, infirming, or confirming predictions, it will continue retraining on the back, in the cloud, actually, on Azure, and get a more accurate model that you can actually also share with other people. 8 basically accepts image levels annotations, so cats and dogs from photos, point base if you have to count, bounding boxes if you want to detect, or pixel level annotations if you are into land cover and land use map. And as a built-in, as a number of deep learning models from the state of the art. But you can upload your own if they are in PyTorch, in TensorFlow, or you name the framework that you like. And the good news about all this, and then I will close because I think that I am right on time, is that everything is can actually download it and play with it right now immediately. Microsoft agreed to make the whole core code to be completely open. So have a look to the paper here that we have impressed at me, and most importantly, get it and use it for your own tasks. And it is already being used, so we're starting projects now with interested parties. For example, here we are detecting migratory birds in Western Africa, and in 4.5 hours, including the model training, we detect 21,000 birds, which is what takes usually the ecologist at Quest 3 weeks of manual counting. So, I mean, it works. So, I know it was short. I know I talk very fast. I hope you have enjoyed something different and a problem that made you travel a little bit to Africa or everywhere you can find wildlife. I also hope that you see that it's not only about having a data scientist knowing how to train a deep learning model, but you need a multidisciplinary team and understanding really all the ins and outs of the problem. And, well, I think that this is the future. So having data scientists together with problem experts and making the difference, in our case, for nature conservation. So thank you for listening, and thanks to all the wonderful people here. I put some picture. They worked in all these projects I presented today, and they deserve some credit because I'm just the guy speaking, and these are all the brain power who made it happen. Thank you very much.